Hello everyone. Today we are going to learn about basics of trigonometric ratios, where a brief explanation will be given about different types of functions under trigonometric ratios. So in the coming slide we'll be explaining about what's trigonometry. First we need to understand what exactly is trigonometry. So trigonometry is a branch of mathematics which deals with the study of relationship of sides and angles of a right angle triangle. Yes, to be precise, trigonometry applies only for right angled triangle and not to every triangle. It is used to determine the value of unknown or missing sides and angles of a right angled triangle. For example, two sides of a triangle are given. We can find out the third side with the help of a single angle present. Okay, at least one angle and one side should be available to find the other sides of the triangle or angle. So the angle should be measured in degree and radians. Angle which is available in the triangle, it should be available in degrees or radians. The most commonly used angles for calculations are 0 degree, 30 degree, 45 degree, 60 degree and 90 degree. There are fixed values which has been available to find out the values of triangle, and these values are fixed for all these mentioned angles which you can see in your screen. These values are fixed. They have been found out, and with the help of these values we can find out the value of other sides of the triangle. Coming to next about trigonometric functions. Trigonometric ratios of a triangle are also called as trigonometric functions. Trigonometric functions totally gives the value of sides or angles whatever we are supposed to find out. Now we'll figure out how exactly to find out the missing sides or angles of a right angled triangle. There are 6 functions: sine, cosine, tangent, secant, cosecant, cotangent. In the bracket the abbreviation is written. For example, for sine it's sin, which is pronounced as sine. For cosine it's cos, tangent tan, secant sec, cosecant cosec, cotangent cot. So if you can see, sine, cosine and tangent and secant, cosecant and cotangent, they are inversely proportional. Like secant is the inverse of sine, cosecant is the inverse of cosine, and cotangent is the inverse of tangent. So we'll be studying more about these functions in the coming segment. There are 3 parts of a right angle triangle, as you all know: base, perpendicular and hypotenuse. Hypotenuse is always the longest side of the right angled triangle, and perpendicular will always be the shortest side of the right angled triangle. So coming next, we'll be learning about different trigonometric functions. So first is sine of any angle. For suppose, if you can see in your screen, there is a right angled triangle ABC and theta is the angle of A. So for suppose we are supposed to find out the sine of theta. Sine theta is perpendicular by hypotenuse, which is also side opposite by hypotenuse, and which is, as per the figure, side opposite is A and hypotenuse is C. The value of hypotenuse is C. So sine theta is equal to A by C. Next is cos theta. Cos theta is always base by hypotenuse or side adjacent. Side adjacent means the angle which we are talking about. For example, in this triangle we are talking about theta. So theta, the side adjacent to theta is B, AC, B. So the small letter B, yes. So AC by AB, hypotenuse is always AB. So C, so that's why B by C. Next is tan theta. Tan theta is equal to perpendicular by base, which is side opposite by side adjacent, which is also sine theta by cos theta. Tan theta is always sine theta by cos theta, and which is equal to, as per the given figure, A by B, the value the small letter A by B. Next is sec theta. As I told you, the inverse of sine theta, so 1 by sine theta is equal to C by A. Cosec theta is 1 by cos theta, so it's C by B. And cot theta is opposite of tan theta, which is sec theta by cosec theta, or 1 by tan theta is equal to B by A. Coming next to trigonometric angles. To find out the angles, if two sides of the right angle triangle are known, we can easily find out the angle. How? In the last presentation, in the last slide, we have seen that if sine theta is equal to A by C, so if suppose A and C are known, so we can find out the theta by bringing sine inverse of A by C. So we'll be explaining next. If you see, yes, theta equal to sine inverse of A by C, only if A and C are known. If suppose B and C are known, so theta will be equal to cos inverse of B by C. Similarly, if A by B is known, like perpendicular and base is known and hypotenuse is not known, you can either find out the hypotenuse by Pythagoras theorem, that is square root of A square plus B square equal to C, or you can find out directly by theta, tan theta's formula, which is theta equal to tan inverse of A by B. Now coming next to example, if suppose A is 2 cm, A means BC, the length of BC is given 2 cm, and C, which means hypotenuse, length of AB is given 4 cm. So side, if we are talking about theta, so side opposite is given and hypotenuse is given. So if we are talking about side opposite, then sine is involved. So theta equal to sine inverse of A by C, which is sine inverse of 2 by 4, and 2 by 4 we are bringing it to simpler ratio, which is sine inverse of 1 by 2, and sine inverse of 1 by 2 is 30 degree. So how 30 degree, how this value came, we'll learn about this in the next slide. This is the table which I was talking about earlier, where the values are fixed. You need to mug up the values. For 0 degree, sine theta is 0, cos theta is 1, tan theta is 0. Similarly, you will have to mug up. If you watch the trigonometric table properly, you can see the value of sine 0 is equal to value of cos 90. So this works diagonally, which means sine 0 equal to cos 90. Okay, and if you see sine 30 and cos 60, both values are same, that's 1 by 2. Similarly, sine 45 and cos 45 both are same, 1 by root 2, and sine 60 cos 30, the value are same, that is root 3 by 2. So the values work diagonally, so it will be easier for you to mug up the values of this fixed angles which has been found out. Similarly, tan will be sine by cos. So if you know the values of sine and cos, you can find out tan by simply dividing sine and cos, or you can learn or you can you can mug up the values of tan theta also. Similarly, cosec, sec and cot will be the inverse of sine, cos and tan respectively. So coming next to applications of trigonometry, where exactly trigonometry is used. Its applications are in various fields like oceanography, seismology, meteorology, physical science, astronomy, acoustics, navigation, electronics, etc. Wherever distance and angle is involved, trigonometry is used. For example, it can be used to measure the height of mountain, distance of long rivers, height of a building, and for example, if you want to calculate the size of your shadow, you can simply find out using trigonometry. So that's for today. Thank you very much.